Relative design acquisition, a computational approach for creating visual interfaces to steer user choices. We mainly motivate our problem from the following scenario with a shopping website. On the bottom right, we have two buttons that prompt the user to click either Purchase Amazon Prime or Continue Without. The two buttons are designed differently to steer user choices. The Buy button is more bright in color and has text with greater impact, whereas the Continue button is less colorful and more faded. We turn the top button as the reference design because it is optimal in attracting user attention and hence a reference, whereas the bottom button is a relative design to the top button. Motivated by this scenario, the research question we want to address is, can we come up with a computational method that allows us to generate these visual relative designs with respect to a reference design based on user feedback? The method we come up with is called relative design acquisition, which we shorten as RDA. One possible application for RDA is that in Google Maps. Currently, the most desired path is shown in blue, whereas the other options are grayed out, as shown. However, a secondary preferred option can be designed with relative design acquisition to be relative of a shade of blue or border strength with respect to the reference most desired path to prompt the user path taking. This could be used, for example, in alleviating the overall traffic in an area. Following these examples, we mathematically formalize the problem into what we call relative design acquisition. The process is as follows. First, multiple designs are proposed to users from which we collect the ratings on the visual interface. We term this as the absolute rating task, as shown on the left. Next, using this data, we can construct a surrogate model of design performance. We use Gaussian processes to construct this model. We use the model and data then to generate reference designs. And given the reference design and the model, we can generate a relative design of a certain quality, which is parameterized by gamma. If gamma is close to 1, then that means the reference and relative designs should be of similar quality, so they should almost be indistinguishable. If gamma is closer to 0, then that means that the reference design is going to be of a much higher quality than the relative design. In this case, we expect the user to pick the reference design over the relative design. We then show the reference and relative designs to the user in an A/B comparison test in which we get a comparative rating of how much the user prefers one design over the other. We term this as the comparative rating task. We seek to understand the factors affecting relative design acquisition for the design of visual interfaces with 3 studies. In study 1, we focused on relative design acquisition for visual context-free interface design in the mental context of a shopping website. The following task shows the continuous slider interface used for the absolute rating task for the button design task, and as well as for the comparative rating task. They are also similar for the absolute rating tasks and comparative rating tasks for the text design task, as shown here. Note that this is a continuous slider and the user can drag the slider to the extent in which he or she believes that they prefer one design over the other. We found in the study that the comparative ratings can be controllable by the quality of the relative design, and this approach is able to capture individual preferences. This is true for both the button design and text tasks. As we can see here, there is a difference in the comparative rating for different gammas or quality factors of the relative design, showing this approach's efficacy for individualized preferences. And this one shows the distribution of ratings for the button task. In study 2, we focused on relative design acquisition for visual interface design in the visual context of a shopping website. So the following shows the absolute rating task and comparative rating task for the two different website scenarios, namely the blue button rating task and the green button rating task. So it looks very similar to the setup in study 1, but now we have a visual context. We found in the study that the comparative ratings can be controllable by the quality of the relative design. So this method is also effective for scenarios where there is a visual context, and the two methods in which we sample data in order to create the surrogate model are effective in generating relative designs for individualized preferences. In study 3, we focused on relative design acquisition for a new group of users by generating relative designs that could steer user performances for a group of individuals. So here are all the different types of relative and reference designs we generated for the 4 different types of tasks for a group of users, and we wanted to see if we could control their preferences as a population. And in this study, we found that we can generate relative designs that capture group preferences. And what is more interesting is that we can as well capture the quality of the relative design in the amount of time it takes for the participants to finalize their comparative rating. So if gamma is larger, that means that it takes more time for people to decide which one of the reference or relative designs they preferred. Overall, our method shows promise in generalizing to many scenarios where multiple choices are presented and users are nudged to make a certain choice. We can conclude that relative design acquisition is able to capture individual preferences in a controllable way with gamma, and many sampling methods work well with relative design acquisition, and that the relative designs generated can translate to preferences for a new group of users, affecting their decision times. So some applications, further applications for this, could, for instance, be in a desktop application where less useful tools are suboptimal in their visual appearance. And interface designs with more advanced features can be adjusted in quality depending on user proficiency, such as in training wheels for user interface. Please read our paper for further details on the method and experiments.